Well folks, welcome back to the workshop to another how-to power tool repair video. Today we've got a faulty Milwaukee Impact driver. This one is the M18 FID2. This one's been left in for repair. I was assuming it's the bit holder because the bit's still stuck in it, but that's not the case. A little bit more serious, this one. Motor's good, but driving nothing. Normally we get these ones in, Milwaukee's especially, any motor problems, we just generally don't really work at them, don't fix them at all, unless it's something like a bearing, because once you get a problem with the motor where they stop running, they're not worth fixing. Gearbox though, you can do something with this. So we'll actually see if we can fix this one. Normally you get them in like this, it's the bit stuck in the holder. Sometimes they rust in or get broken. You have to actually dismantle the wee tool holder and either change the wee spring or change the balls to get it working again. Or sometimes even just knock it out and get a bit of grease into it. But that's not the problem here. The problem is inside the tool holder. So we're going to see if we can fix this here one up, and hopefully for cheap, because if it's the rotor that's gone, if the gear's sheared off or come loose, it will be an expensive fix. Now excuse me if my words seem a wee bit slurred here. I'm just back from the dentist and half my mouth is completely numb. Nothing too major, just a quick filling. But I still had to numb it. I'm going to that dentist for a while now, and that's the first time he's ever actually put in a general anaesthetic or a local anaesthetic. Normally he just drills away and does the filling because it's never too serious, but this one must have been a bit deeper. So if I sound a bit funny, that's just because half my mouth doesn't work. Right, serious bit isn't the problem. So the rotor looks okay. Sometimes these gears can eventually, if they're getting a lot of work and a lot of impact, and sometimes they come loose and start spinning, and once they spin they round off the shaft, and that's it. They'll not grip the shaft anymore. These are just pressed on to the rotor shaft here. If that happens, you have to replace the rotor and more than likely the rear cover as well. But this one looks okay. Actually seems to be turning it. We'll get in deeper and have a quick look. I have no parts for this either. I don't stock any of the parts for this gearbox, but I might have a scrap one. But if you're at home and you don't have a scrap one at home, you can still order the parts in, because Milwaukee do supply the parts inside the gearbox. You're not stuck if there's a problem inside. Different story when it's a motor. Now some of these have a wee ground lead on them. This one doesn't. It's just literally a motor unit, clamshell, a rotor and a gearbox. The stator, the switch, the controller, the battery retainer, the secondary mode selector switch down here, these are all one piece. So if anything goes wrong here, that's it. You may as well just scrap it and buy a new one and get one with a warranty again, because it wouldn't be worth replacing all this here. It'd still be cheaper than buying a new one, but a new one's got a warranty and this doesn't, even if we replace this part. The only other thing is just maybe the LED and the wee change lever. That's about it. That's all that's really in it. Most of the bits you get for it are inside of here. Quick wee wipe down to clean the dust off, and we'll get on there. Nothing fancy in these ones. They're just sitting here. When they're nice and fresh, that's not a problem. But when they get old, this becomes very slack and makes them very rattly inside. But right now it's not a problem. So the question is, what is the problem? I was thinking maybe broken gears, but they're not broken. So The rotor has this gear on it and it's driving these gears on the inside. When these drive, when these turn, they're running around this outer gear, causing this whole thing to spin. And look through the problem down in there, look. So the two steel balls, they're not really in the right location. And this actually looks like it's compressed. So the anvil down in here is okay. So this is the anvil connected onto your tool holder. This has just been knocked and spun around. And it's this part here, the hammer, that's actually driving it. So that part of the wings here on the anvil down in there sit on this, and this actually turns it. Whenever it meets resistance, this whole hammer gets compressed back, runs over the top of them their wings, and then drops back down again and slams around. But if one of the wee steel balls break in here, and if another bit of debris gets in, I can push it down and get wedged, jammed down, and won't come back up again. So it's say this is compressed and the wings aren't actually attached to anything. So the wings of the anvil are probably just completely missing this your hammer width. You actually see that. So the shaft actually goes into the anvil. So the wings inside go as far as here. As you can see when this turns in, this hammer width, these actual wings on the end of it, will be completely missing these here parts of the anvil down in there. So it's not going to be driving anything. So we have to compress this more to get out these steel balls to see what's jamming it and see if we can free it out and get new balls into it. Just give this a wee clean down. Now this is not what these here pullers are actually for. They might actually do this here. What I'm going to do is just compress this spring. You can use a vise. I normally have a wee steel pipe that goes into the bearing press so I can push it down and still access the middle of it. But I cannot find it. So I'm going to have to try this. This might be a little bit more risky because if it goes wrong, it's going to go flying. Steel balls seem like they're moving. They can't come out either because this is actually in the wrong location. And I can't really spin that. I wonder if that's free enough now. If they're moving, well, let's go back. Kinda. Don't think it went back fully, but it definitely moved. Try it again. See if they're in the right location now. So they have to be in the center to get to these two wee slots here to be able to fit them out. Sometimes one of them can just get damaged. One of the steel balls, that is. It's not what any man likes to hear. Never wants to hear about a damaged ball. I've seen them just crack in half and break. But even if they chip, they can get snagged, cause resistance. There's one. Two. I'll let the pressure off of this now because I don't want to let go the way it is. So we can have a good proper look now. Just be careful down on this side because there is steel balls in here, acting like a little linear bearing. And fingers is the best way to test for debris. See how it feels. See if you find anything sharp or rough. That actually feels fine. And that seems fine. In other words, I don't see what's going on here. There we go. Get the zoom lens on. See this one? Seems absolutely fine. But the other one is what can sometimes happen. It's actually deglazed or chipped. See one end of it? See, there's like a layer, like an onion. Piece is actually peeled off, so it's no longer round and it's got a sharp edge. You can see there what's happened. So these will be hardened, but the hardened piece is actually cracked off. So that's not running smoothly inside this track. It's going around and getting caught and digging in and can't move. So the actual hammer weight isn't able to slide up and down. This should be sliding up and down and up between these tier 2 tracks. If it jams, it's going down and just again stuck and not going up anymore. So what we need is a single steel ball to get this here running again. Let's see what size this is first. Don't lose the other one. So 4, that's the damaged one. Yeah, 4.75 mil. You'll have to see if with anything like that, you'd have to have close to that. 5 mil would actually be too big. 4.5 would be way too small. So you're going to need 4.7 or 4.8. See if with anything like that. I'll just get rid of that one for now. We'll try the lucky dip box here first. .75. Would I be wrong with that? One of them. The hardest part about this repair is just going to be clamping this here, or compressing it. So you can either use a 3-jaw puller, but an even better one would be a 2-jaw puller. Just get rid of that before you get it mixed up. This is the bit you have to be careful with. Don't use a screwdriver because that's now magnetized because I was fixing a magnet earlier. So was that one. That's better. Get one that's not going to attract these things. Even this one's a little bit magnetized. That should be alright. As well, this one. Don't be worried about this bearing. If you go to turn it and it doesn't shift, the bearing's not the outside, that's actually part of this here spindle. The bearing's the inside. This little washer then is just holding on these 2 pins that actually hold the gears. Before you compress, make sure you get the peak of these here little V's. You line it up with these here. So whenever that ball goes in, it'll go into this track and then drop onto the V. If you don't line it up, it won't fit in. That anesthetic's starting to wear off now. We're starting to feel the tooth. Actually, it's not even the tooth I'm feeling, it's my cheek. That's why I don't like getting anaesthetic when I go to the dentist. Because that numb, you don't know what you're doing. Feel something in my mouth earlier on, you start chewing onto it. You realise then it's your cheek you're eating. So I've actually probably just bruised my own cheek. It's not a nice thought of going to the dentist and I'm drilling into your tooth without being numbed. But if it's not deep, you don't feel anything anyway. And once it's over, you can actually just get up and get on with your day. You don't have to mess around waiting for your mouth to come back to normal again so you can drink or eat. Press that all the way down. Again, just be careful that spring or the clamp doesn't slip. And that's shifted now on me. Don't know if it'll still fit or not. Yeah, we'll try and see. Yeah, goes on. Get the other one on. Make sure you get onto the two separate tracks because they're not connected. Make sure you don't drop them onto the exact same one. And then back it out. Again, nice and carefully. That's the two balls. Actually hold that in place. That's it. So you see where that spindle should be sitting. When that anvil sits on there, it's going to be engaging the wings of the hammer. So that should be her. Just drop a wee bit of grease onto that, just to help it once she starts going. Doesn't take much, mind you. Line up them gear teeth so that slides in. Just give that a wee wipe. Don't need to worry about the inside, but we'll just clean the outside. And bearing the outside's still good as well. And I'll push that on. Line up the housing. So this little cutout matches the gearbox here. And that's it. That's us good to go. I'm just going to give us a quick wee blow down with the compressor just to clear away the dust. That's it cleaned down. That's here then. Just drops straight on. There's no wee earth clamp on here now, it's actually on the body. It wraps around to here. And the earth actually gets screwed down onto this here part. So it's not screwed onto this anymore. So it makes it very easy to remove it. This is a wee job you could easily do at home yourself, as long as you have a way to actually compress that spring. You could also use a vise if you have that. But the clamp, bearing press or bearing puller is a far easier job. I don't like the rag in Milwaukee too much. Wouldn't be a fan of them, but this is not isolated to them. This can happen any brand. At the end of the day, it's the steel ball that's actually failed and they don't manufacture the steel balls. Might order them on. Maybe that's just a cheaper brand they're using. But you can't really tell just from a 4.75mm steel ball. Happens to the D-bolts as well, and the odd time it does, I do see it on the Makitas too. They either snap in half or they chip off like that there. And it just jams up the hammer and your drill or impactor, even the big nut guns, same thing, same mechanism. The motor will run, but it won't drive anything. Aye. That should be it. one Milwaukee Impact driver, the M18 FID2, with one 4.5mm or 4.7mm steel ball into the gearbox to actually free it up again. Those were the easiest and cheapest fixes to do. It was the armature back here, but quite expensive. It was the gears, you had to order them on specially, but very easy to pick up a wee steel ball like that there and replace it. Compress it, take out the ball, put in a new one, and that's it. You couldn't ask for an easier repair than that there. Anyway, that's her. That's how you fix up your Milwaukee Impact driver, or if it's a nut gun or any other brand of nut gun, that's how you fix it up if your motor's spinning and your anvil's not turning. Anyway folks, as always, thanks for watching. If you're liking the tool repair videos, make sure to drop us a wee like and a follow down below. But till next time folks, I'll chat to you next time. Cheers!